Hello everyone, welcome to our channel. Let's learn together. In this video, we'll start with the properties of Laplace transforms, where I'll be writing all the Laplace transform at one place for now. Later, I'll explain each of the properties of Laplace transforms with an example so that you'll understand a bit more clear. So first, I'll write all the properties of Laplace transform at one place. Okay. So first, it is a linearity property. So for this linearity property, we are applying the Laplace transform and finding it. So the linearity property is C1 f of t plus C2 g of t. And we are applying Laplace transform for this linearity property, which is C1 is constant, C1, C2 are constants, and f of t and g of t are functions. So two different functions. So Laplace transform of this linearity property will be C1 into Laplace transform of f of t plus C2 into Laplace transform of g of t. Next, second property is change of scales. So this change of scales is f of t, and we are applying Laplace transform for this change of scales, which is 1 by a into f of s by a, and we can also write this as 1 by a into f of s for s tends to s by a. And next is first shifting property, where we are applying Laplace transform for this first shift. So considering if Laplace transform of f of t is f bar of s, so first is we are applying Laplace transform for this first shifting property, which is e power at f of t. So we get it as f bar of s minus a. So we can also write it as f bar of s, where s tends to s minus a. Similarly, the Laplace transform of first shifting property for e power minus at f of t will be f bar of s plus a, where f bar of s tends to s plus a. Okay. Now coming to the second shifting property. You are understanding, right? This is the properties. We are applying Laplace transform for these properties. So second shifting property, same, if Laplace transform of f of t is f bar of s, if Laplace transform of f of t is f bar of s and g of t is equals to f of t minus a, where t is greater than a, and g of t is 0 for t is less than a, then the Laplace transform of g of t will be e power minus as into f bar of s, or Laplace transform of f of t minus a plus into h of t minus a will be e power minus, this is f, okay, e power minus a into f bar of s, where h of t minus a is equals to 1 for t greater than a and 0 for t less than a. So for the second shifting property, these are the Laplace transforms. Okay. Now we'll go to other property, which is Laplace transform for derivatives. Okay. So Laplace transform for derivatives will be Laplace transform of derivative means f dash of t, right? We represent the derivation of f dash of t, which is s into Laplace transform of f of t minus f of 0. Similarly, the double differentiation of f of t. So the Laplace transform of double differentiation of f of t will be s square into Laplace transform of f of t minus s into f of 0 minus f dash of 0. Similarly, and so on till derivative of fn of t is equals to s power n into Laplace transform of f of t minus s power n minus 1 into f of 0 minus s power n minus 2 into f dash of 0 and so on till f of n minus 1 f power n minus 1 of 0. So this will be the Laplace transform of derivatives. Next we'll go for other property, which is Laplace transforms for integrations. Okay, so if this is different, okay, if Laplace transform of f of t is f bar of s, then the Laplace transform for integrations, right? Integral 0 to t, integral 0 to t, and so on, integral 0 to t f of t, and so on dt will be f of s by s power n. Don't worry, I'll explain every property of Laplace transform with examples. I'm just writing all the properties of Laplace transforms at one place, okay? Next property of Laplace transform for multiplication, where if the Laplace transform of f of t is f of s, then the Laplace transform of multiplication, that is t power n into f of t, will be minus 1 whole power n d power n by d into s power n into f of s. So next property will be Laplace transform for division by t power n. So if Laplace transform of f of t is f bar of s, then Laplace transform of f of t by t power n will be integral s to infinity, and so on, integral s to infinity f of s and so on ds. Okay, next. So we'll go with next one, which is the property of periodic function. So the Laplace transform for periodic function, if f of t plus capital T is f of t, then the Laplace transform of f of t will be integral 0 to capital T e power minus st f of t by 1 minus e power minus s capital T dt. Okay, so these are all the properties of Laplace transforms. We'll discuss in detail about each property of Laplace transforms in detail with examples. Please do check the upcoming videos. Thank you. Thanks for watching. Do like, share and subscribe for more videos.